More and more researchers are focusing on cultured algae to produce biodiesel to replace traditional fossil fuel. Algae do not compete for land and space with other agricultural crops, and algae can survive in water of high salt content or yield water that was previously stored as unusable. The most important reason is that algae can produce much more oil than any other crops. However, there are too much algae species in the world. Each one has different algae biomass concentration and lipid content. Therefore, we need to find a suitable algae species for research and further large-scale application. In order to locate the fast-growing algae, we use a lot of flasks and photobioreactors to culture algae, and we use pumps and large amount of culture media to dilute algae in order to find fast-growing algae. After we find a fast-growing algae species, we can optimize the culture media to push the algae to accumulate lipid. This lipid can be used to produce biodiesel to reduce the dependence on traditional gasoline. Current state of screening system is using fax to screen algae. Its principle is to use dye to label the lipid in algae and use electrical field to separate algae. This method cannot find which algae grow fast, so we have to culture algae by 96 well plates or flasks. This culture work will be labor-intensive and time-consuming, and the flask will also have impact on different algae. However, MEMS need only a little volume of reagent and can culture different algae under exact same conditions in only one chip, so we can compare the growth rate of different algae and get to know which one to select. The challenge is that algae will sediment on the chip and become biofilm during growing. This will prevent light penetrate the chip and make algae do not disperse well in the culture room. I'm going to etch 10 culture media reservoirs of different volume range from 100 microliter to 1 milliliter on one single chip. Use built-in pump to pump the culture media in to dilute algae. The flow rate of culture media is about 4.2 microliter per hour. If algae grow fast than this rate, it can survive in chip. If not, it will be washed out.